we chose to evaluate how stress relates to activity in common spaces. As students living on such a tight-knit campus, we are constantly surrounded by our peers, whether it's in the classroom or at home. For many individuals, interactions with others can help relieve stress, but for some, it can lead to more. As we approach final exams, we thought it would be particularly interesting to see the ways in which these interactions affect the already existing levels of stress due to the nature of finals period. Based on our findings, we hoped to create a tool students could use to help anticipate stress levels as related to surrounding activity and to prepare appropriately.
To quantify activity levels and stress levels in common spaces, we decided to use Wio boards and sensors. This is a Wio board. It is a programmable board to which we can attach any Wio Link sensor to collect data. To quantify activity, we chose to define activity as a measure of loudness and motion. We used Wio sensors to measure these variables. This is a loudness sensor, and this is a motion sensor. This is a button sensor. We had people interact with and push the button as a subjective measure of stress. To actually get the data from these three sensors, we used If This Then That, a web-based service using conditional statements to automate various devices and systems. With If This Then That, we created various applets to detect new events within each sensor. When an event is detected, the applet added the new data into a new row in Google Sheets with timestamps. For instance, the loudness sensor would collect a data point once per minute, and the applet would input this data point into the Google Sheet. For the motion and button sensor, an event occurs when each sensor either detects motion or is pushed, respectively speaking. Once the event occurs, the data is inputted into the Google Sheets.
After setting up each Wio board and automating all of the data collection, we placed the 4 identical boards in an apartment common space at various locations. One board was placed at the entryway of the apartment, one next to the kitchen stove, and one at the kitchen table. A sign was left next to each sensor informing people to press the button sensor 2 times if they felt very stressed, 1 time if they felt a little stressed, and not at all if they felt no stress. These sensors were left collecting data nonstop for 3 days. After collecting data, we looked at each Google Sheet and analyzed the data for trends. From these trends, we developed a user interface for people to see the trends in stress and how it relates to motion and loudness, mapped out on a floor plan of the apartment. On this interface, users can choose what time of day they would like to view.
This data can be used in a variety of ways. For one, it can help students better understand their stress habits. Perhaps under stress, students are more likely to rush out of the home and forget to turn off the stove. By becoming more aware of these stress habits, students can take steps to prevent unsafe kitchen and common space conditions. Additionally, this data could help inform smart home devices about what times the user is most stressed. Then, the smart home could anticipate stressful periods of the day and aid the user in relevant tasks to reduce stress levels. For example, if students are rushed to get to class in the morning, perhaps a pre-made breakfast would ease stress. In the future, for our system to collect more accurate data, we could use wearable sensors to collect biological data specific to the user. For example, we could record heart rate and sweat to determine how stressed the student is. By collecting less subjective data, we could generate more accurate reports of user stress.